So in this video we're going to look at the solution process when the characteristic polynomial has two real roots. So let's consider the case where we guessed that our solutions were the form y equals e to the rx. We plugged our y and its first and second derivatives into our differential equation, and we've got ourselves into the position like we did in video 1 where we have to solve the characteristic polynomial. So if the characteristic polynomial has two real roots that you find either by factoring or by completing the square or using the quadratic formula, whatever method you use to find those two roots, let's suppose that it has two real roots. R1, R2 are real numbers, and R1 isn't equal to R2. So this is case 1. So if we find such values r sub 1 and r sub 2, then we're really getting two solutions. We're getting y1 equals e to the r1x, and we're getting the second solution that says you can choose to do e to the r sub 2x, and this would be a second solution. And so what we want to remember from the video in which we did all of the preliminary theory, if we have a second degree polynomial, we're trying to find two solutions, y1, y2, where y sub 1 and y sub 2 are linearly independent. And if we can find y sub 1 and y sub 2 linearly independent, then our general solution is going to look like a constant times y sub 1 plus a constant times y sub 2. And this will be the general solution to our second order linear differential equation. So we definitely have, if we can find, if we have two real roots that aren't the same, then we do have two solutions. And what we need to do is calculate the Wronskian of those two solutions, e to the r sub 1x, e to the r sub 2x, and verify that they're indeed linearly independent. So to calculate the Wronskian, we get e to the r sub 1x, e to the r sub 2x, the derivatives r sub 1e to the r sub 1x. Derivative of this one is r sub 2e to the r sub 2x. And the Wronskian, or the determinant of this 2 by 2 matrix, is just going to be r sub 2 times, the bases are the same, e times e, so we get to take the sum of the exponents. We get r sub 1x plus r sub 2x minus the product of the other diagonal. We get r sub 1 times e to the r sub 1x plus r sub 2x. And the only way for this difference to be equal to 0 would be if r sub 2 were equal to r sub 1, which we are assuming it's not. We're assuming that our characteristic polynomial has generated two distinct real roots. So because r sub 1 doesn't equal r sub 2, we know that the Wronskian is not equal to 0, which tells us that we have a linearly independent pair of solutions to our second order differential equation. So the general solution is just going to look like this. It's going to look like y equals c sub 1 e to the root 1x plus c sub 2 times e to the root 2x. So this is the simplest possible case. We get two real roots. Then here's the solution. In the homework document that I'm going to send you and remind, I'm going to have a summary of each of the three solution methods to make it a little bit easier for you to organize and remember the solution methods.